Hello guys, so welcome to our YouTube channel once more. Today we are going to be solving Maths Mechanics 2007. So again, projectile motion question number 3. So I'm here with one of our students, Jane Ahone, which I call her Jenny, by the way. So she's just going to read the question so that we can head over to the solution. All right, Jane, over to you.
A particle is projected from a point at a height 3h meters above a horizontal playground. The direction of projection makes an angle alpha with the horizontal to the point of projection. Show that if the greatest height reached above the point of projection is h meters, then the horizontal distance covered by the particle before striking the plane is 6h cot alpha meters.
Alright guys, so that's the first part of the problem. We would head over to the second part of the problem, which would earn you a total of 13 marks. So every single question in A-level Maths Mechanics earns you 13 marks. So let's go to the last part of the question. Jenny, over to you.
Find the vertical component of the speed of the particle before it hits the playground. 13 marks.
Perfect guys, so let's dive right into the solution. Let's look at the solution to the problem. So we have the problem there. Now I'm just going to illustrate the diagram over here. The key things about the diagram is that the particle is projected from a height 3h above the ground. So we will come over here and project the particle here. So these are horizontal. The particle goes all the way and then comes back down here. So we also know this, we are told in the question that the maximum height reached by the particle above the point of projection is h, right? So what you really want to do is that you want to use every single piece of information that's given to you in projectile the best way you can. Information is not just shown to you out there like that. So once we define what maximum height is in projectile motion, of course, it's u squared sine squared alpha on 2g. That's the maximum height from the point of projection. No, good. So we can go over and then we define now the complete vertical displacement by this particle. So if it comes from here all the way here, the displacement at this point is 0. So if it comes back all the way back to this plane, you realize that the complete vertical displacement will just be negative 3h. So we'd have s equals to ut minus half gt squared, and then in place of s, of course, we're talking about y because it's our vertical displacement, and then u here is just uy because we're talking about again the velocity in the vertical, the initial velocity in the vertical plane, which is just u sine alpha, because you resolve this u here, it becomes u sine alpha minus half gt squared, right? So we want to come over and then in place of our y here, since the complete displacement of the particle is negative 3h, we put in place of y negative 3h, and then we have that ut sine alpha minus half gt squared. What you want to do is that this equation is already a quadratic equation in terms of t, so you want to rearrange the quadratic equation in terms of a, b, and c. So this is me rearranging it here. So if you arrange it in terms of a, b, and c, you can basically use your quadratic formula and then you get the values of t. Now the various values of time of flight would just be negative b plus or minus square root of b squared. Our b squared here is u sine alpha u squared. I have u squared sine squared alpha minus 4ac. So our a is g over 2, our c is negative 3h. So you multiply all of that together, you have 6gh, all that over 2a. So our 2a will simply be 2 times g over 2, which gives us just g here. So that's our quadratic formula applied. So what we want to do now is, now come over to this maximum height reached by the projectile. That's an information given to you. Again, I say you have to exploit every information that's given to you in projectile motion. If I come over here and I cross multiply, my u squared sine squared alpha will simply be 2gh, right? Now in place of this u sine alpha, I would simply have the square root of 2gh, right? Because my u squared sine squared alpha is 2gh, the u sine alpha will become square root of 2gh. So our t therefore becomes root 2gh here, plus or minus. In place of this u squared sine squared alpha, again it's just 2gh. I put 2gh here plus 6gh, it gives us 8gh, all that over g. So what we want to do is, of course, if we add these two guys, because I will not subtract, this square root of 2gh is obviously smaller than the square root of 8gh, and I know that times a scalar, I cannot be negative, so I'll basically ignore this part where you're subtracting those two values. I'll just add them. So I'll take 2gh root of that plus 8gh root of that. Basically we can just get that to be, now in this place of 8, what you can do is that you can write 8 as 4 times 2, then square root of 4 is just 2, so you actually have 2 root 2gh. Added to root 2gh, you have 3 root 2gh, all that over g. So that's your time right there. Now if you want to write your time back in terms of u and sine alpha, remember that 2gh is u squared sine squared alpha, so square root of 2gh will simply be u sine alpha. So I can, in place of my t now, I can actually write it as 3u sine alpha over g, right, if I want to write it back in terms of this. So that's the first part of the problem, but then you have not still gotten the proof, so you have to go all the way to the proof. Now what you have to do here is that if I want to calculate the horizontal displacement of the particle, right, I simply have to take the time of flight of that particle times the velocity in that direction, and the velocity in that direction is simply the x coordinate of this initial velocity. It does not change since gravity does not act in that horizontal direction. So you have your u equals alpha times t, gives you the total displacement in the x direction. So but then our t, again, remember that it's time of flight, and we've gotten it up here to be 3u sine alpha on g, so you just put it in there. That's your x. So what you do is you want to multiply those things out. You have 3u squared sine alpha cos alpha on g, then you go over to say, all right, so our x then is, again, take note that your u squared sine squared alpha on 2g is all of these guys. So in place of now here we have u squared sine alpha, right? So in place of u squared sine alpha, we can conveniently put 2gh over sine alpha, right? Now but then what I've actually done is, okay, so what you really want to take note of again is that over here you have u squared over g. Then at this particular point in our proof we have u squared over g. So what you want to do, you want to replace this u squared over g with h, because if I'm just going to come here and make u squared over g the subject, I'm going to have 2h over sine squared alpha. So in place of u squared over g here, I'm going to put 2h over sine squared alpha. That's what I have. If I simplify this, of course this sine alpha will go with one of the sine alphas here. Cos alpha over sine alpha gives me cot alpha. Then 2h times 3 gives me 6h cot alpha, which is exactly the proof. So let's head over to the next part of the question. Okay, so the last part of the question says find the vertical component of the speed of the particle just before it hits the playground. Okay, so again, before it hits the playground, we are talking about the vertical component of the speed. So again, you use equations of motion but in the vertical plane. So we have vy equals to ui minus gt. Again, minus of course particle was projected upwards, right? So our Vy is going to be, what's our initial vertical velocity? Again, is u sine alpha minus g. What is our time of flight? We got our time of flight in the initial part of the question, which says 3u sine alpha on g. So we go ahead and we simplify, g goes off, so we have u sine alpha minus that. We basically have our negative 2u sine alpha meters per second. So that's the vertical component of the velocity. That one was straightforward. So guys, I hope you enjoyed the video. If you liked it really much, please just put thumbs up down there, right? Hit on the like button, share the video, the link, right, to your friends so that they can also come over here and enjoy some science. And then please subscribe. Thank you so much for supporting us. See you next time.